Alright, in this video we're going to do some problems where we will be condensing and expanding logarithmic expressions like these. Okay, we're going to expand and condense. And we do that using these three properties of logarithms. And this is a two-way street. We can go from this to this, or from this form back to this form. So everything you see on the right, these are considered to be expanded. And everything you see on the left, this is considered to be condensed. All right, expanded and condensed. Anyway, if you have the log of multiplication, then that can expand as two logs that are being added. Or you could go the other way. If you see two logs that are being added, you could write one log using multiplication. And then that's the product property. The quotient property involves division. If you have the log of division, it expands as subtraction. And if you see subtraction of two logs, you can write it as a single log of division. And finally, the power property. If you have the log of something with an exponent, you're allowed to take that exponent and move it to the front. That's what's happening here. The power property. So we're going to use those three properties. When you are condensing, you're taking these multiple logs and we're going to write them as a single log. Okay? So actually on this problem, we're going to do all three of those rules. Because I see addition, all right, that's your product property about to happen. I see subtraction, that's your quotient property. And I see these numbers in the front, the 3, the 2, the coefficients. And that's all about the power property. So well, let's do the power property first. We have to do the power property first. So the power property, when you're condensing, says that if you have a number in the front, coefficient, you can move that up into the exponent like this. So that's what I'm going to do. So this 3 is going to move to the exponent, and this 2 is going to move to the exponent, and that's it. So I'm going to have natural log, that's an L, by the way, not an I or a 1, ln. So we have natural log 6 plus, but then we'll have natural log x to the third power minus natural log y squared minus natural log 5. Okay, that was the first step. Now, let's go to the black screen for a quick second. Okay, in terms of when you have the quotient property and the product property all in one problem, you know, I'm telling you addition becomes multiplication, subtraction becomes division, but what about when I have them all together in one problem? So say if I have, let's see, I'm going to say log base q of a minus log base q of b plus log base q of c minus log base q of d. Okay, so I have the quotient rule and the product rule all mixed in together. The way you can do that, in one step, you can write a single log, and because of the subtraction, you know there's going to be a fraction involved. So it's just a matter of what's going to go in the numerator and what goes in the denominator. Well, any positive term is going to give you something in the numerator. Any negative term is going to go to the denominator. So up here we're going to have the positive, and down here we're going to have the negative. Okay, so log a, that was positive, so a goes in the numerator. Minus log b, so the b goes down here because it's negative. Plus log c, that's positive, so the c goes in the numerator. minus log d. That's negative, so the d goes in the denominator. So looking back at this problem, as soon as I see that I have a minus, I know I'm going to have a quotient, a fraction. So I'm going to have, and just instead of log, I'm going to have natural log. So I know I'm going to have a fraction. Now, anything positive goes in the numerator. So this is positive, so the 6 goes up here. This is positive, so my x to the third power also goes up here. This is negative, so my y squared is going to go down here. This is also negative, so my 5 is going to go down here. And traditionally, we put the numbers in front of variables, so I did that as well. So that would be my final answer for number 11. Okay, take a look at number 12. Again, when you're condensing, the first thing you want to do is take care of your power rule. So this 3 is going to become the exponent. And this 1/2 is going to become the exponent. So this is going to be rewritten as log base 5 of x to the third power minus log base 5 of y to the 1/2 power. Okay, now I see the subtraction, so that means the quotient rule. So this would be log base 5 of x to the third power over, whoops, I almost wrote the log twice. By the way, when you do the quotient rule, notice you don't write the log twice. You just have one log and then you have your fraction. I don't put natural log in the top and the bottom. Here when I do this quotient rule, I'm not going to put log base 5 in the top and the bottom. You just write it once. So x to the third power. Now down here I'll have y to the 1/2 power. But you shouldn't leave it like this either. When you're condensing, don't leave it as a fractional power. Go ahead and remember that 1/2 power is the same thing as square root. So what you really want to have is x to the third power over the square root of y. All right, if you want full credit, you're going to want to do this. Okay, so that's condensing. The next couple problems will be expanding. All right, so notice we're starting off with square root. When you're expanding, you're going to go from square root to the 1/2 power. Okay, so this is a little bit tricky. First of all, please understand that this a is not a base. Okay, this is like having log base 10 of a to the third power and then the rest of it. The a is not a base, it's not low, it's not a subscript. Okay, now, so this square root is the same thing as the 1/2 power. So what I have here is I have 6b, and that is to the 1/2 power. But you can't treat the 6b as a package. These are two separate things, so what you really need to do is split it up. So this is log, so I have a to the third power. So both of these are to the 1/2 power, so let's write that separately. So this will be 6 to the 1/2 power, and it will be b to the 1/2 power. All right, so it's really three separate things. Now this is all multiplication, so when we expand this, it's going to be all addition. So this will be log, and we'll have a to the third power plus log 6 to the 1/2 power, and then plus log b to the 1/2 power. Then all you have to do, remember your power rule. If you have an exponent, you can put it to the front. So the final answer will be, all right, that 3 is going to go to the front, the 1/2 is going to go to the front, and this 1/2 is going to go to the front. So that'll give us 3 log a plus 1/2 log 6 plus 1/2 log b. And that's your final answer for number 13. All right, and number 14, expanding this. So you see it's a fraction, so you know that we're dealing with the quotient rule. So this should expand out as subtraction, so that's what we're going to do. When we expand this out, we're going to have natural log 4 minus natural log, you know what, I like to do my L's this way. So we'll have natural log 4 minus natural log 7x squared. Actually, hold on. I changed my mind. I started to do this in 2 steps, but I want to do it all in 1 step. Let's go back to the black screen like we do. Remember when we did this and I had expanded form and I condensed it all in 1 step and just the positive stuff went in the top and the negative stuff went in the bottom? Well, hopefully you can see that I could have done that in reverse. All right. In fact, I'll just scroll this down. Say if I gave you this first. You know what? I'll just make new variables. Why not? Say if I had, let's see, W, P, X, R. Say if I had this. I could expand this all in 1 shot. Just anything, because of these 4 things, I'm going to have 4 terms when I expand this out. And anything that's in the numerator is going to be a positive term, and anything in the denominator is going to be a negative term. All right, and I'm going to erase the Q just because I don't feel like writing Q over and over again. So that would give me log W, all right, that's positive because it's in the numerator, plus log P, all right, again, that's positive because the numerator. Now these 2 are in the denominator, so that would be minus log X minus log R, all right, those 2 are negative because they're in the denominator. Now imagine that, let's put some exponents on some of these. All right, say this P was squared. All right, so then that would be like this. Let's say that this R had the square root. Okay, so that square root is a 1/2 power, so that would be like this. Let's see, what else? Let's say this X had a, now I'll do the W. Let's say this W had a cube root. Well, that cube root would be the 1/3 power on the W. So we'd have one more step to do. Each of these powers would need to end up in the front. So this 1/3 would move to the front for the final answer. This 2 would move to the front, and this 1/2 would move to the front. So then this would be the final answer. Okay, so that's what's about to happen here. Now looking at this problem, we have 3 things. We have this, and we have this. So that's why I'm going to have 3 log terms. So I'll have natural log 4, I will have natural log 7, and I will have natural log x squared. Now, the first one is positive because it came from the numerator. The other 2 came from the denominator, so they will both be negative. All right, so last step, this exponent has to move to the front. So the final answer would be natural log 4 minus natural log 7 minus 2 times natural log x. So that would be your final answer for number 14. All right, I'm going to stop this video here because we're about to switch gears. On the next video, we're still going to be expanding and condensing, but we're going to be given a few facts like this, and using only a 4-function calculator, we're going to evaluate expressions like this, which are not actually on the table. You won't find it here.